Okay, today's lesson is matrices. Now I'm going to do a bit of a warning up front. Matrices are technically not part of this course. However, they are a very, very useful tool in solving stuff in this course. And of all the things that I teach, all the renegade and crazy stuff that I do in the course, one of the things I get back from students coming back from university who take sciences, maths, engineering, they say, thank God you taught matrices. So matrices is it's a topic that I'll incorporate into the material. You don't have to use them, but you can see where there's a huge advantage. So what is a matrix, or what today's goals? First of all, I can use a matrix to solve a problem requiring the solution of 3 equations, 3 unknowns. And I can use this skill to help interpret and better understand the interactions between lines and planes. So at this point, this is going to be the sketchier part, because we haven't really talked about lines and planes involving 3 equations, 3 unknowns. So it's more, I'm just going back and focusing on what you know from grade 10. All right, and we're going to review what you know from grade 10. So matrices are used to help analyze systems of equations. So that's what you did in grade 10 with elimination and substitution. You analyze systems of equations. For systems of equations, there's 3 possible outcomes. So independent, you have a unique solution. So that means you get an answer. All right. So going back to grade 10, you would do elimination, substitution, you'd get a coordinate, you get an answer, it's independent. Dependent. Dependent means there's an infinite number of solutions. That would mean that from grade 10, one line was on another. And for us, now in grade 12, that means that they're collinear. Just kind of bringing everything together. And inconsistent, no solution, that would mean that you had 2 parallel lines. They didn't intersect. And whether you had a whole lot of answers or questions like that in grade 10, those are actually your 3 possible outcomes. They cross at a point, they're the same line, or they're parallel. There is no solution. Okay? So that's going back, and I'm going to do a little bit more of that a little later on. So what is a matrix? A matrix is an array of data. And what it does, when we refer to a matrix, we refer to a matrix. It's always in the form row by column. Now keep in mind, when I'm talking about matrices here, you could go through university and take 10 or 15 matrices courses. I'm teaching you a very, very, very pinpoint topic within matrices. Matrices is a huge area of study in their application, so keep that in mind. So what are we talking about? So some examples. What would a 2 by 3 matrix look like? Well, 2 would indicate that there's 2 rows, and 3 would tell you how many columns. All right, so that would mean that I would have 2 rows of numbers and 3 columns. So that would mean I'd have 2, 3, 5. I'm making the numbers up here, 6, 7, 8. And the matrix has square brackets. So there is your 2 by 3 matrix. So we have, oops, that's not the one I wanted. So here's the 2 rows. All right, and here are the 3 columns. So 2 by 3. If I wanted a 4 by 2, that means I'd have 4 rows, 2 columns. 1, 2, 3, 4, 5, 6, 7, 8. So that's what a 4 by 2 matrix would look like. Again, number of rows, number of columns. And what we're going to be interested in, what we're working with, is 3 by 4s quite often. And that's the main focus, or where I'm going to be heading in the direction we're heading in. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. All right, so there's our row by columns. All right, and inside each matrix we have what's called elements. Okay, so for example, just using this as our example, the 2 by 3 here, we would have element 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. And each number inside a matrix is given an address. Okay, so A11, the 1, 1 gives you row column. So it tells you row 1, column 1. For A12, I'm in row 1, I'm in column 2. For A23, I'm in row 2, and I'm in column 3. So it's like playing Battleship or Risk, or sorry, Battleship. So you're given a location as to where to go. Okay, so if we go with the 3 by 4, for example, so from there, the following values are, so A12, A34, A52. So A12, for example, so what is the value in row 1, column 2? So row 1, column 2 would be a value of 2. Okay. What is the value for the number in row 3, column 4? So row 3, column 4, give me this value right here. So it's our 12. And trick question, row 5, column 2. You'll find that there is no row 5, so not applicable. All right, so we're using that as our coordinate system. All right, so turn the following values for the matrix below. I'm going to change that particular question a little bit because I want to talk about systems of equations. So determine the, let's cross this out, resulting system for the matrix below. Actually, do I even want to do that? It's kind of an egg and chicken part here as to what I want to show you. So what's going to happen? We're going to do operations with matrices that reduce them to systems that look like this. So maybe what I'll do for this is I'll set them up, and then we might have to come back and finish this screen up a little bit later. So for example, 1, 2, 3, 0, 1, 2. So I'm going to start with, this is what it would look like in grade 10 if you were to use matrices. 1, 2, 3, 0, 0, 0. I think that's what I'm going to have to do, because now that I start thinking about this, it's not going to make a whole lot of sense at this point in time, I don't think. So I'm gonna leave this for a second. Don't erase it. Don't scratch it out, because we are going to come back to this. All right. I'm going to move on, and I'll come back to that. Because you need to know what we're actually driving for first before you can come up with summary or conclusion, or anticipate what you're going to end up with. So let's look at rules of matrices and systems of equations first. We'll start with that, and then we'll move on from there. So what are the rules? There are 3 of them. First one is you can multiply any row, and I can't stress this enough, row only, any row by a non-zero scalar. So you multiply any row by anything you want. Okay? Think about when you're doing elimination. When you were doing elimination, sometimes you had to multiply one equation by 3 to get it so you can cancel out the variables. Exact same concept here. You multiply any row by a value, any value that you want. So that's rule 1. Rule 2, you can add, subtract any multiple of one equation to another. Well, that's the exact same as what you did with elimination in grade 10, because you were adding and subtracting 2 equations together. So it's the same thing with matrices, it's just there's no x's and y's to worry about. And the third one that you didn't have to worry about, you can interchange the rows at any time. And the reason you didn't have to worry about that, you're only working with 2 equations, so there's no benefit for you to flipping it upside down. All right. So there are 2 forms that we're driving for here, and I'll show you each one. The first form, it's going to look like this. So you're going to have 1, and maybe I'll stick with numbers, 1, 2, 3, 4, and then 0, 1, 2, 3, 0, 0, 1, 5. Okay, this is what we call echelon form. Echelon form. Okay, echelon form has ones on the diagonal. Okay, and for each column, it's in the order 1 and then all zeros, 1 and 0, and then the 1. Okay, so the bottom left corner, okay, is all zeros. All zeros. So that's what our echelon form will look like. And I'm going to talk about, don't worry about the how yet. We'll get to that in a second. How we're going to use it or how do we get to that, that's coming. The other form that some of you are going to, if you go into engineering specifically, if you go into a pure math, you're going into a math field, you have to go into you have to get it to reduced echelon form. This is not the one I bother teaching. It's too many steps for what I want to get out of it. But I'll show you what it looks like. You'll find that it looks very similar. Okay, so this is what you call row reduced echelon form. I'm just making you aware that it exists. Echelon form. You never ever have to use this for me. It has ones on the diagonal, and now if you look in each column, it's only ones and zeros in the first 3 columns. Okay, so that's what we call row reduced. It takes a little bit longer for what we want to do. Okay, so the only way I can really explain how matrices work is by going through and doing an example. It's really the only way this will work for us, because just doing it theoretically, sitting there talking about it, is not going to help you. So I'm going to do some examples. It's going to be confusing off the start, so you need to be patient and follow as best you can, and what you're going to find is the more you practice it, the more efficient you get with it. So we're going to do a couple of examples with that.